How were the pyramids built in ancient Egypt? This question has intrigued a huge number of people for a long time. It seems that there must be something more behind it than just human labor, the intervention of higher powers or forgotten knowledge. But what if the secret lies not in magic, but in ingenious organization, astonishing precision, and simple yet incredibly effective tools? What if the whole truth about the construction of the pyramids has always been before our eyes, hidden in details that we overlooked? Watch the video to the end and you will learn what simple natural element allowed the Egyptians to create perfectly flat foundations covering tens of hectares, and how ordinary water helped them cut granite, one of the hardest stones on the planet. Imagine not the sight, but the sound of the great construction on the Giza plateau. It was not a chaotic noise, but a coordinated rhythm that did not stop for decades. Thousands of people worked as a single mechanism, and this mechanism had its own unique soundtrack. The main sound was the continuous pounding of dolerite balls on limestone and granite. The craftsmen in the quarries worked in sync, their blows merging into a single hum, like the roar of distant waves. This sound carried for miles around, announcing the great work. Against this backdrop, the sharp and short commands of the overseers and foremen could be heard. They used simple phrases that were understandable to every worker, regardless of their origin. These commands set the pace and coordinated the efforts of hundreds of people at the same time. Another important sound was the creaking of huge wooden sleds sliding across the sand. The monotonous, drawn-out sound of multi-ton blocks moving was a symbol of the continuous process. It signaled that another stone giant was on its way to the construction site. Periodically, this hum was interrupted by dull thuds. This was the workers using wooden levers and their own weight to put another block in place. Each such blow meant a small step towards the completion of the great project. The workshops echoed with the piercing screech of copper saws cutting through stone. This sound was only possible thanks to the abrasive sand that was constantly sprinkled under the blade. It was evidence of the painstaking work involved in giving the blocks their perfect shape. And on the pyramid itself, on its growing tiers, there was a different noise. It was the sound of grinding and fitting facing slabs. The craftsmen worked with incredible precision, and their tools made a subtle, almost musical screech. In the evenings, when the work quieted down, other sounds carried over the builders' settlement. These were songs, conversations, and laughter of people relaxing after a hard day. This contrast between the daytime hum of construction and the evening calm was part of the life of an entire generation. Together, these sounds created a unique symphony of construction. It told a story of human perseverance, organization, and the pursuit of eternity. This soundtrack has long since fallen silent, but its echo still lives on in the stones of the Great Pyramids. We would be very interested to hear your point of view. What do you think about the soundtrack of such large-scale projects? Write about it in the comments. The construction of the pyramid did not begin with the first stone, but with the selection of the ideal location. This was a decision on which the fate of the entire project depended. A mistake at this stage could have made further construction impossible. The main criterion was the presence of a solid rock foundation. The pyramid weighed millions of tons, and only solid bedrock could withstand such pressure without subsiding. Engineers conducted thorough geological surveys to find a suitable plateau. The second important factor was proximity to the Nile River. Stone for construction was delivered by water from distant quarries. The location of the construction site near the shore greatly simplified logistics and saved time. The site had to be on the west bank of the Nile. In ancient Egyptian mythology, the west was associated with the world of the dead, and all tombs were located there. This was not an engineering requirement, but a sacred one, which was strictly observed.
Drive the stakes here. Yes, right here.
After choosing the location, one of the most critical stages began: leveling the foundation. The base area of the Pyramid of Cheops is more than 5 hectares. Achieving a perfectly horizontal surface on such a huge area was an incredibly difficult task. To do this, Egyptian engineers used an ingenious and simple method. A low dam made of clay and stones was erected around the future construction site. The entire fenced-off area was then flooded with water. The surface of the water created a perfect horizontal level. Workers marked this level on the rock foundation around the entire perimeter. After that, the water was drained, and the builders were left with precise markings. Then the painstaking work of removing all irregularities began. Workers chipped away at all areas of rock that were above the marked level. The remaining depressions were filled with stone blocks and rubble. The result was a perfectly flat platform with a deviation from the horizontal of no more than 2 centimeters. This accuracy amazes even modern engineers armed with laser levels. It was the key to the stability of the entire future structure. The final stage of preparation was the application of precise markings. Using ropes and measuring instruments, engineers marked the contours of the future pyramid on the prepared foundation. Particular attention was paid to the orientation to the cardinal points. But how did the ancient Egyptians achieve such precise orientation of the pyramids to the cardinal points, with an accuracy of hundredths of a degree, without compasses or modern instruments? The answer to this question lies in their profound knowledge of astronomy, and we will reveal this secret in the next chapter. The precision with which the pyramids are oriented to the cardinal points has long remained one of the greatest mysteries. The Pyramid of Cheops is oriented to the north, with an error of less than 1/10 of a degree. Achieving such a result without modern instruments seems impossible. The secret of the Egyptian engineers lay in observing the stars. They did not use the North Star, as one might think, since at that time, due to the precession of the Earth's axis, it was not located at the pole. They had another, more complex and accurate method. To determine true north, they used a method of observing circumpolar stars. These are stars that never set below the horizon. Egyptian astronomers chose one bright star and tracked its movement throughout the night. A vertical pole was dug into the center of the future construction site. A perfectly circular wall was built around it, high enough that an observer from the center could not see the horizon. This wall served as an artificial horizon, eliminating any interference. The astronomer marked 2 points on the wall: the place where the chosen star appeared from behind the wall in the evening, the rising point, and the place where it disappeared behind the wall in the morning, the setting point. These 2 points were symmetrical relative to true north. Then, using a rope and a plumb line, the exact middle of the arc between these 2 points was found. A line drawn from the central pole through this middle point indicated true north with incredible accuracy. This method required patience and a clear night, but it gave flawless results. Once the direction of north had been determined, the other points of the compass were determined using simple geometric constructions. The Egyptians mastered the art of constructing a perfect right angle using a rope triangle with sides of 3, 4, and 5. This allowed them to create a perfectly square base. This astronomical precision had a deep sacred meaning. The pyramid was not just a tomb, but a machine for elevating the pharaoh's soul to the stars. Its orientation to the cardinal points connected the earthly structure with the cosmic order. Each face of the pyramid was associated with a specific celestial phenomenon. The north side was directed toward the eternal, never-setting stars, which symbolized immortality. Correct orientation was necessary for the pharaoh's successful journey to the afterlife. Thus, the construction of the pyramid was not only an engineering task, but also an astronomical one. The ancient Egyptians demonstrated a deep understanding of the structure of the universe. Their knowledge in this field still inspires admiration and respect. The basis for the construction of the pyramids was stone, which was quarried in huge quantities. Limestone, which was quarried directly on the Giza plateau, was used for the main body of the pyramid. This greatly simplified logistics and accelerated construction. The extraction process was labor-intensive and required a high level of skill. Workers first marked the contours of the future block on the surface of the rock. Then, using copper chisels and stone hammers, they dug deep trenches along these lines. When the block was separated from the rock on 3 sides, the most difficult stage began, separating it from the base. To do this, the workers dug horizontal pits under the block. They inserted dry wooden wedges into these pits. The wedges were then doused with water. The wood absorbed the moisture and expanded with tremendous force. This force created a crack in the base of the block, and after a while, the multi-ton block separated from the rock mass with a dull thud. Granite was used to build the inner chambers and sarcophagi. It was mined in Aswan, almost 1,000 kilometers south of Giza. Granite is much harder than limestone, and different tools were needed to work with it. Instead of copper chisels, workers used balls made of dolerite, an extremely hard volcanic rock. They methodically struck the granite with these balls, chipping away at it and gradually creating trenches. It was exhausting work that required incredible patience. A special snow-white limestone was used to clad the pyramids. It was quarried in Tura, on the other bank of the Nile. This stone was of high quality and, after polishing, shone in the sun, creating the effect of a solid monolith. Each block extracted was carefully checked for cracks and defects. Any flaw could lead to the destruction of the block during transport or installation. Only perfect blocks were sent to the construction site. Work in the quarries was organized with remarkable efficiency. There were specialized teams. Some were engaged in marking, others in digging trenches, and still others in separating blocks. This specialization made it possible to maintain a high pace of work. The quarries were the first and one of the most important stages in the complex chain of construction. It was here that the giant stone bricks were born, from which the greatest structure of the ancient world was then built. The quality of work at this stage determined the quality of the entire pyramid. What aspects of the organization of labor in the quarries do you find most well thought out? In the next chapter, we will learn how these giant blocks were transported from the quarries to the construction site. Transporting millions of stone blocks weighing between 2 and 70 tons was one of the greatest logistical challenges of antiquity. The Egyptians solved it with ingenuity and efficient use of natural resources. The main transport artery was, of course, the Nile. Granite blocks from Aswan and white limestone from Tura were loaded onto huge barges. These ships were built of cedar and could carry hundreds of tons of cargo. Loading and unloading such heavy blocks required the construction of special docks and the use of complex lever systems. Traveling along the Nile was the easiest stage of transportation. The barges moved northward with the current, and in the opposite direction, they used the power of the wind and sails. The annual flooding of the Nile was particularly convenient. The water rose, and it was possible to bring the barges almost close to the construction site. To transport the blocks overland, the Egyptians used large wooden sleds. The blocks were securely fastened to the sleds with ropes. Then dozens, and sometimes hundreds of workers pulled these sleds along specially constructed roads. These roads were true engineering structures. They were leveled, compacted, and covered with a layer of clay or limestone chips. This reduced friction and made it easier for the sleds to move. The secret to effective transportation on sand was to moisten it. Modern experiments have shown that if a certain amount of water is poured in front of the sleds, friction is reduced by half. The Egyptians knew this secret. In many images, you can see a person pouring water in front of the sleds. For moving particularly heavy blocks, such as granite beams for the Pharaohs' chambers, roller systems could be used. However, most blocks were probably transported on sleds. It was a slower but more controllable and safer method. The entire transportation system required flawless coordination. It was necessary to coordinate the work of the quarries, the river fleet, and the ground crews. A delay at any stage could halt the entire construction project. There was a whole hierarchy of managers responsible for logistics. They kept track of the blocks, planned routes, and allocated labor. Thanks to their work, the flow of stone never stopped for a single day. This grandiose conveyor belt, which operated for decades, is one of the most impressive achievements of ancient Egyptian civilization. It demonstrates their ability to solve the most complex logistical problems without the use of wheels or draft animals on an industrial scale. The most discussed and controversial issue in the construction of the pyramids is the method of lifting blocks to a great height. It is obvious that ramps were used for this purpose. However, there is still no consensus on the exact design of this ramp. The simplest and most obvious theory is a straight ramp. It could have run perpendicular to one of the sides of the pyramid. As the structure grew, the ramp became longer and higher, maintaining an acceptable angle of inclination. The drawback of this theory is that to reach the top of the Pyramid of Cheops, such a ramp would have to be more than a mile long. The amount of materials needed to build it would be comparable to the volume of the pyramid itself. In addition, after construction was completed, such a ramp would have to be dismantled, which would be a colossal task. Another popular theory is the spiral ramp. It could have encircled the pyramid on all four sides, rising in a spiral. Such a structure would have required significantly less material than a straight ramp. However, this theory also has its weaknesses. A spiral ramp would cover the edges of the pyramid, which would prevent engineers from controlling the angles of inclination and the accuracy of the masonry. In addition, it would be very difficult to maneuver multi-ton blocks on the turns of such a ramp. There is also a theory of an internal ramp. According to this hypothesis, the ramp could have been located inside the pyramid itself. The blocks were lifted up an internal corridor that spiraled along the outer walls. This theory explains why no traces of large external ramps have been found outside the pyramid. However, it does not explain how huge granite beams for the internal chambers could have been lifted in turn in such a narrow corridor. Some researchers suggest that the Egyptians used a combination of different methods. For example, a straight ramp could be used up to a certain height and then replaced by a spiral or zigzag ramp. This would allow the advantages of different designs to be combined. Regardless of the specific design, the construction and maintenance of the ramp was in itself a complex engineering task. It had to be constantly extended, reinforced, and maintained in working order. The surface of the ramp was probably covered with clay and moistened with water to facilitate the sliding of the sleds. Lifting the blocks up the ramp required the coordinated efforts of hundreds of workers. They pulled the sleds using thick ropes made of palm fiber. The rhythm of their movement was set by special signals to ensure an even distribution of the load. Which method of lifting the blocks seems most logical and effective to you? In the next chapter, we will look at how the craftsmen achieved a perfect fit of the stones at the very top. After lifting the block to the desired height, the builders faced a new challenge: installing it in place with millimeter precision. The artistry of the ancient Egyptian masons still amazes the imagination. The gaps between the blocks in the inner chambers of the Pyramid of Cheops are so small that it is impossible to insert a knife blade between them. Before installation, each block underwent final processing. Craftsmen adjusted its dimensions and checked its flatness and angles. To do this, they used simple but precise tools: plumb lines to check verticality, squares to check right angles, and straight slats to check flatness. Wooden levers and rollers were used to install the heavy blocks in place. Workers were able to lift and move multi-ton blocks with incredible precision. This process required not so much brute force as an understanding of the laws of physics and coordinated teamwork. The Egyptians used gypsum mortar, but not as cement as in modern construction. The mortar served more as a lubricant. It was applied to the lower block, making it easier to move and install the upper block. As it hardened, the mortar filled in the smallest irregularities and ensured a perfect fit. The masonry of the inner chambers and corridors was particularly difficult. This required not only precision, but also the ability to work in a confined space. The walls and ceilings of these rooms are made of giant granite blocks, fitted together without the slightest gap.
Push it up.
The construction of the so-called Grand Gallery in the Pyramid of Cheops is the pinnacle of engineering. Its walls are made of 7 rows of limestone blocks, with each subsequent row overhanging the previous one. This creates a unique stepped vault that evenly distributes the enormous pressure. The blocks were laid in rows, from the outer edges to the center. The last keystone in the center of the row required particular precision during installation. After completing one row, the builders filled it with rubble and sand, creating a level working surface for the next level. The builder's skill was not limited to the interior masonry. The exterior finish of the pyramids was no less impressive, and it was this that created the image we have lost. The modern appearance of the pyramids is only the skeleton of a grandiose structure. In ancient times, they looked completely different. The pyramids were clad with slabs of white, polished limestone, which was brought from the quarries of Tura. These facing blocks were perfectly shaped and fitted together with incredible precision. They created a smooth, monolithic surface that shone in the sun. The ancient Egyptians called the pyramid Akhet Khufu, which means Horizon of Khufu. The installation of the facing slabs was the final and most critical stage of construction. The slabs were laid from top to bottom as the construction ramp was dismantled. Each slab had a complex shape to ensure a perfect fit and the correct angle of the edge. Master masons worked at great heights on narrow ledges. Their work required not only skill, but also great courage. They polished the already installed slabs, bringing their surface to a mirror-like shine. The result was a structure that reflected sunlight and was visible for tens of kilometers. In the rays of the rising and setting sun, the pyramids probably took on a pink or golden hue. It was truly an unforgettable sight. The top of the pyramid was crowned with a special stone, the pyramidion. It was carved from a single piece of granite or limestone and had a perfect pyramidal shape. The pyramidion was the most sacred element of the structure. The pyramidion could be covered with electrum, an alloy of gold and silver. It was the first to catch the rays of the rising sun and the last to see it set on the horizon. This symbolized the pharaoh's connection with the sun god Ra. The completion of the pyramid's construction was a great celebration for the whole country. It was a triumph of engineering, organized labor, and deep faith. The construction of the pyramid was not a chaotic process, but a clearly organized national project. Its implementation required the mobilization of enormous human and material resources. The city of craftsmen, located near the construction site, played a key role in this. Archaeological excavations have shown that the pyramid builders were not disenfranchised workers, but skilled craftsmen and hired laborers. They lived in a specially built settlement with streets, houses, bakeries, and even a hospital. It was a real city designed for thousands of inhabitants. The workforce was divided into teams, or phils, which were in turn divided into brigades. Each team had its own name, such as Friends of Khufu or Intoxicated by Khufu. This system created a spirit of competition and increased productivity. The workers worked in shifts. One group worked on the construction site for several months, then another group replaced them. This rotation system made it possible to attract people from all over the country to the construction site without undermining agriculture. The state provided for the builders completely. They received regular, high-calorie meals that included bread, beer, fish, and meat. The rations were carefully designed to maintain the physical strength of people engaged in hard labor. Evidence of advanced medical care was found in the builders' settlement. Doctors treated work-related injuries, as evidenced by the remains found with signs of healed fractures. Caring for the health of workers was an important part of the organization of labor. The city of craftsmen was the heart of the great construction project. Here, people not only lived and worked, but also passed on knowledge and experience from generation to generation. It was thanks to these people, their labor, and their craftsmanship that one of the wonders of the world was created. The arsenal of tools used by ancient Egyptian builders was surprisingly simple. They had no iron, steel, or complex mechanisms. Their strength lay in their ability to make the most effective use of what nature gave them: stone, copper, and wood. The main tools for working with limestone were copper chisels and gouges. Copper is a soft metal, so the tools quickly became blunt and required constant sharpening. Hundreds of blacksmiths worked in the workshops at the construction site, repairing and making new tools. Copper was useless for harder rocks such as granite. Here, dolerite, a very hard volcanic rock, came to the rescue. Workers used round dolerite balls weighing several kilograms as sledgehammers, methodically breaking up the granite. Copper saws were used to cut large stone blocks. Copper itself could not cut granite. The secret was the use of an abrasive, quartz sand, which was constantly sprinkled under the saw blade. It was the sand, not the saw, that did the main work. The same method was used to drill holes in stone. A copper tube was rotated, with abrasive sand poured inside and around it. In this way, it was possible to drill perfect cylindrical holes in the granite for installing pins or other structural elements. Simple but accurate tools were used for measuring and marking. Wooden squares allowed for the construction of perfect right angles. Plumb lines, consisting of a stone and a string, were used to check vertical surfaces. Water levels were used to level surfaces and check horizontality. These were simple gutters filled with water. Long, straight slats were also used, which were placed on the surface and checked for gaps underneath. Thick ropes made of palm fiber and wooden levers were used to transport blocks. The Egyptians were masters of the art of using levers, which allowed them to move enormous weights with minimal effort. This set of tools may seem primitive by modern standards. However, in the hands of skilled craftsmen, they became a powerful tool for transforming the world. The genius of Egyptian builders lay not in the complexity of their technologies, but in their remarkable efficiency. It was this combination of simple tools, deep knowledge of physics and geometry, and impeccable organization of labor that allowed them to create eternal monuments that continue to amaze us today. This is the main secret of pyramid construction. We conclude our journey into the world of ancient Egyptian builders. Today we have seen that it was not magic or extraterrestrial technology that stood behind the creation of the Great Pyramids, but human genius at its finest. It was a symphony of precise calculation, coordinated organization, and incredible craftsmanship. Every stage, from the choice of location to the placement of the last stone, was thought out in detail. Tools that seemed simple at first glance worked wonders in the hands of the masters. And the system of labor organization made it possible to manage a project whose scale is still impressive today. The pyramids are not just tombs for pharaohs. They are a monument to human perseverance, intellect, and the ability to unite for a great cause. They remind us of what a person armed with knowledge and unyielding will is capable of. Which engineering aspect of pyramid construction impressed you the most? Was it the cosmic precision of their orientation, the ingenious method of leveling the base, or the complex logistics of transporting the blocks? Share your thoughts in the comments, and don't forget to subscribe to our channel to continue unraveling the mysteries of ancient civilizations with us.